In last lecture, we have discussed about Bayes theorem on conditional probability. It is based on partition of sample space, and from original sample space, we pick up one event, and with the help of that event, we try to find probability of getting a particular partition. That is the use of Bayes theorem. In examination, you can identify application of Bayes theorem as performing the experiment in two stages. First stage, we select the partition, and at the second stage, we select the item from that partition. So two-stage experiment is nothing but a clue to apply Bayes theorem. We'll try to understand today the application of Bayes theorem with some examples. Example number 1, we have bag 1 which contains 6 blue, 4 red balls. Bag 2 contains 2 blue and 6 red balls. Bag 3 contains 1 blue and 8 red balls. This is the information given to you. So I can say the information related with balls is distributed in 3 partitions. I call bag 1 as first partition, bag 2 as second partition, bag 3 as a third partition. Now on this information, I write bit 1. A bag chosen at random and a ball is drawn randomly from the bag. It turns out to be blue ball. Find the probability that bag 1 was chosen. This is your first question on this information. Number 2, a bag is chosen at random and 2 balls are drawn without replacement at a time from the selected bag. If both balls were blue, find the probability that bag 2 is chosen. So bit 1, I want to get a probability of selecting partition 1 by using a knowledge of selected ball is of blue color. In bit number 2, I want to find the probability that partition 2 is going to be selected by using information both balls of blue color. Now here you are making an experiment in 2 stages. Stage number 1, you are selecting a bag. After that, stage number 2, from selected bag, you are picking the item, that is a ball. That's why it is a 2-stage experiment. And whenever you performing 2-stage experiment, that is the application of Bayes theorem. Let us proceed how to solve this problem. You have third bit, we'll try to see after finishing number 1 and 2. Let us define event as a partition of omega. We have A1, A2, A3 as per your last lecture. I define A1 as bag 1 chosen randomly, A2 bag 2 chosen randomly, A3 bag 3 chosen randomly. So we have probability of selecting bag 1, bag 2 and bag 3 1 by 3 respectively. It gives an equal chance for every bag because my selection is on the basis of random. There are 3 bags. I pick only one, so chance is 1 by 3. Now, according to bit 1, I define another event from omega. B equal getting a blue ball. Now, for this event, I calculate chance of getting blue from A1. In bag 1, total balls are 10. Out of 10, there are 6 blue. So chance of getting blue from A1, 6 by 10. Chance of getting blue from A2, 2 by 8. Chance of getting blue from A3, 1 by 9. So that is a simple application of classical definition of probability. 6 by 10, 2 by 8, 1 by 9. Chance of getting blue from partition 1, partition 2 and partition 3. These calculations are required to get Bayes theorem. What is the question asked? We want to find probability selecting bag 1 by using a knowledge the ball selected is blue. This equal, according to Bayes theorem, chance of getting A1 multiply chance of getting B from A1. Total divide same calculation as numerator, but for all 3 possible partitions, 1, 2, 3. P of AI multiply P of B given AI. The next step is very simple. Put the values what we calculated before. Chance of getting first partition 1 by 3. Chance of getting blue from first partition 6 by 10. In the denominator, there will be 3 additions because there are 3 partitions. This is the calculation for partition 1, same as numerator, plus chance of getting second partition, multiply chance of getting blue from second partition, plus chance of getting third partition into blue from third partition. And now after this, you can simplify by algebra or by calculator, you will get the answer. Now my second bit in the question is, suppose I selected 2 balls and question says, if both are coming blue, find the chance the partition second is selected. So probability of B given A1, that means getting a 2 blue from A1. There are 6 blue. I want 2, so 6 choose 2. Divide by total balls in partition 1, 10. Choose 2. See the way of calculations. Here I pick up only 1 ball. So directly 6 choose 1 is 6. 10 choose 1 is 10. That's why I have not written the combination formula here. But now I'm selecting 2 balls. So I have to write from 6, I choose 2 as a favorable cases for blue ball. Total ball are 10. Number of selections 10, choose 2. Similarly, chance of getting both blue from A2. Second partition, second bag, 2 blue, I select 2 out of 8. So 8C2 denominator, 2C2 numerator. Chance of getting both blue from third bag. In third bag, you can see what the information says. Information says there is only one blue. But bit number 2 says, I pick up 2 balls and I want both blue. So for this information, this event is impossible. And if the event is impossible, corresponding probability always 0, because there is 0 possibilities. So third calculation is 0. I want to find probability selecting second partition by using a knowledge of B. Bayes theorem says chance of selecting second partition multiply chance of selecting blue from second partition. Denominator addition for all 3 possible partitions. Do the calculations as bit number 1. Chance of getting A2 1 by 3 into chance of getting both blue from A2. 2C2 is 1, 8C2 is 28, so it is 1 by 28. Probability of A1 into B given A1 plus A2 and third is 0. Simplify by calculator. Now, what is the third part says? In the question, third part says, a ball is selected at random from the bag selected at random. Now, in this case, which bag is selected? Not clear. From that bag, ball is selected. What is the color? Not clear. Question says, find the probability that it is a red ball. So this is not application of Bayes theorem. You can see bit number 2, bit number 1. A bag is chosen at random, and from that bag, a ball is chosen randomly. And then you have information. What? The selected ball is blue. By using this information, what is the chance bag 1 is selected? Whereas in bit number 3, we are selecting a ball from the bag which is selected randomly. I want to find probability that a red ball is selected. Now for bit number 3, we are not asking for partition. We are asking a particular element from entire sample space. And that is why it is not directly Bayes theorem. This is a calculation, probability of getting a knowledge. Red ball is a knowledge. Bag 1 is partition, bag 2 is a partition, bag 3 is a partition. Here I don't want probability of partition. I want probability of particular element. And That is the difference between bit 1, bit 2 and bit 3. Let us proceed how to solve this bit 3. I define event as C equal getting a red ball. Now you have different possibilities. You may get red ball from bag 1. You may get red ball from bag 2. You may get red ball from bag 3. So chance of getting red is equal to chance of getting red ball from bag 1. Now here I write or bag 2 or bag 3. So in the concept of probability, if you are writing or, it is going to be added. So this statement is written as probability getting a red ball from bag 1 plus probability of getting a red ball from bag 2 plus probability getting a red ball from bag 3. So this event which we define on the top going to happen by any one out of these 3 possibilities. To satisfy the event, we don't want all. We want any one possibility. And whenever you want any one possibility, different probabilities are going to be added. Be remember. Therefore, probability getting red from A1 plus probability of getting red from A2 plus probability of getting red from A3. This intersection symbol is for getting red from A1, getting red from A2, getting red from A3. Now use multiplication theorem. Probability of C intersection A1 is P of A1 into probability of C given A1 plus probability of A2 into probability of C given A2 plus probability of A3 into, this is not a plus, by mistake it is plus, it is product, C given A3. This is nothing but, if you look carefully, it is the denominator of Bayes theorem. You can see denominator of the Bayes theorem. Probability of partition into probability of knowledge with partition. And same thing we are writing here. So denominator of Bayes theorem can be asked separately like this. Put the values. Chance of getting first bag 1 by 3. C from A1. Red from A1. There are 4 red. 4 by 10. Plus chance of getting A2 into red from A2. 6 by 8. Plus chance of getting A3 into red from A3. 9 ball, 8 red. Simplify this calculation, probability is 0.6. 60% chance to have a red ball. If you pick up randomly any one bag, and from that bag, if you pick up randomly any one ball, what is the chance to get red? Answer is 60% chance. So that is the application of Bayes theorem to solve individual probability. We have question number 2 related with Bayes theorem. An explosion in a factory manufacturing explosives can occur due to short circuit, defect in machinery, negligence of workers, and sabotage. So this statement gives you different causes which are responsible for explosions in the factory. By past experience, the respective probabilities are recorded. 0.3, 0.2, 0.4 and 0.1 respectively. B, remember, in Bayes theorem, chance of partition altogether should be 1. So explosion occur due to 4 causes. If you add this probability, it should be compulsory 1. In other words, you call this as a partition of the information. The engineer feel that an explosion occur with probability 0.3 due to the short circuit. That means the maintenance engineer has feeling if there is an explosion, chance of explosion due to short circuit 0.3, 0.2 due to the machinery defect, 0.25 due to negligence of worker, and 0.8 due to the sabotage. This total never 1. It may be less than 1, it may be greater than 1. But total of partition should be 1. Now this is the entire information. What question asks? Given that an explosion has occurred, suppose unfortunately at certain day explosion took place, then what is the chance? Determine the most likely cause of the explosion. That means here we don't know whether explosion occurred due to short circuit, due to the defect of the machinery, due to the negligence of worker, or it is due to sabotage. That we don't know. We want to decide it. So chance of having an explosion, we have to decide what is the most likely reason for the explosion. That is the application of Bayes theorem. Let us see how to solve. Let us define the event partition of omega as below. Here we divide partition sample space in 4 parts because there are 4 reasons. A1, explosion occur due to short circuit. A2, due to defect in machinery. A3, negligence of worker. A4, sabotage. It is given that chance of first partition 0.3, chance of second partition 0.2, chance of third partition 0.4, chance of fourth partition 0.1, and this is a condition to be remembered. To apply Bayes theorem, sum of probability of partition should be equal to probability of omega as 1, because total partition is nothing but entire sample space. And axiom number 2 says probability of complete sample space is 1. Let us define other event as a knowledge. What knowledge? Explosion has been occurred. That is a knowledge to you. So chance of getting explosion due to first cause 0.3. Chance of having explosion due to second cause 0.2. Chance of having explosion due to third cause 0.25. Chance of having explosion due to fourth cause, that is a sabotage, 0.8. Now we want to decide the explosion occurs most likely by what reason? Whether it is by short circuit or by negligence of workers or by defect in machinery or by sabotage. That means you have to make 4 calculations of Bayes theorem. Number 1, chance of getting A1 by using a knowledge of explosion. That means probability explosion occur due to short circuit. Apply the statement of Bayes theorem. Put the calculations which are readily available. Answer is 0.29. Chance of getting second partition, that means probability explosion occur due to defect in machinery. Put the statement of Bayes theorem. Get the calculation separately. This is not correct. This is wrong. You have to write entirely like this and then get answer. This is the wrong. Be correct it. Probability is 0.12. Chance of getting explosion due to the negligence of worker. Put the statement of Bayes theorem. Simplify all the calculation. Again, this is wrong. The way should be like this. Do this, repeat again, everybody. Make the correction here. The probability is 0.3225. Chance of getting explosion due to sabotage by using a knowledge of B. This is the statement of Bayes theorem. Again, this calculation is not up to the mark. You do calculation by making this separate way. I will tell you how to do that. P of A4 given, that is 0.8 into P of B given, A4 is 0.1 plus. So this is the numerator. The denominator you have to calculate separately. I think it is correct because we calculate this denominator in the first bit. So denominator is common. So not necessary to make correction. 0.31, this is a common for all calculation. Only the numerator keeps on changing. So 0.31 is common everywhere because denominator is common in the Bayes theorem. So I get 0.25. Now you can see what is explosion due to sabotage. It is 80%. In the information, if you see, chance of having explosion due to sabotage is 80%. But if you try to calculate by Bayes theorem, the probability having explosion is not coming like 80%. It is 0.25. So even though independent cause is larger, but conditional probability is not coming proportional to that. So which probability is larger? This is a larger probability. What is explosion due to A3? What is A3? A3 is nothing but explosion occurs due to negligence of worker. So this third partition is to be taken care of. That means we should keep the watch on the worker rather than short circuit, machinery and sabotage. That says Bayes theorem. Therefore, answer of the question is a maximum than others. Probability of getting explosion due to negligence of the worker is maximum. Therefore, answer of the question is negligence of worker is the most likely cause of explosion in the factory. I will take little bit 5 to 10 minutes more, then that is the end of this chapter. If A and B are mutually exclusive non-empty events of omega, then show that probability of A given A union B equal PA divide PA plus PB. Very simple question based on the conditional probability definition. The information says A and B are mutually exclusive non-empty event of omega. What do you mean by mutually exclusive? That means A and B are separate, they don't have common element. Let us see how to prove the statement. Probability of A given A union B equals probability of A intersection the given event divided by probability of given event, that is the definition of conditional probability. I use distributive law. This intersection distributed inside the bracket. So what you get? Probability A intersection A union A intersection B. Divide by, it is the addition theorem what I taught before. So you have PA plus PB minus P of intersection. Now what is A intersection A itself? That is A only. Union, question says AB are mutually exclusive. So A intersection B is phi. Don't write 0. According to set theory, 0 is an element. So when I say A and B are mutually exclusive, you have to use empty set symbol, that is phi, not 0. What is the denominator? PA plus PB minus 0. Here I write 0. Why? Because probability of phi is 0. So probability is a value. A intersection B is not a value, it is a set, and set denoted by phi. A union phi. Union means plus, phi means nothing. A plus nothing is A. So I get probability of A divided by probability A plus probability of B, that is your right hand side. Next question is, A and B are two events on a sample space omega. Prove that PA equal PA given B multiply PB plus PA given B dash into PB dash. Simple question. Take the right hand side, apply the definition, you will get left hand side. P of A given B is written as probability of A intersection B divided by PB multiply PB plus P of A given B dash written by P of A intersection B dash divided by PB dash. These get cancelled. So I get probability of A intersection B plus probability of A intersection B dash. Let us look Venn diagram. I have complete square as omega. There are two circles, A and other is B. I want A common with B dash. So this is my A common with B dash. Plus A common B, that means this area. So this plus this shaded part is nothing but A by using a Venn diagram. I told this before, P of A intersection B dash written as PA, complete circle of A minus middle part. This intersection cancel with this. So you get plot of A, that is the left hand side. Very simple proof. You can solve this question. Before also we tried and we got the answer also.